Welcome to qnawire.
Over here we want to calculate the pH of a solution of 0.15 molar of potassium cyanide. We're told that the HCN is going to have a pK of 9.21, so we know that the Cn minus ion is going to have a pKb related to that, since we know that pK plus pKb is equal to 14. So in this case, the value for pKb would be equal to 14 minus pKa, which is 14 minus 9.21, which is 4.79. Remember that the pKb is going to correspond to the reaction of Cn minus plus water. This is the basicity constant that is going to produce HCN plus OH minus. In this case, this is the reaction that is relevant to us because the solution that we're going to have is of potassium cyanide. And recall that potassium cyanide in water is going to produce K plus Cn minus. So over here, our ice table is going to allow us to get the value for the pH as the concentration of OH minus. We're going to get POH, and with that, calculate pH. So initially, we're going to have an initial concentration of 0.15 molar of Cn minus. Water is not going to matter because it's a condensed phase. And we're going to have 0 of each of the products. The amount of change, we're going to call it minus x, so we're going to produce plus x and plus x. So at equilibrium, we're going to get 0.15 minus x, and x. Remember that the constant for this equilibrium is going to be equal to the concentration of HCN times the concentration of OH minus divided by the concentration of Cn minus. This is going to be equal to 10 to the minus pKb, which for us is going to be equal to 10 to the minus 4.79. This is a reasonably small value, so we can say that the value for x is going to be much smaller than the value of our initial concentration, which is 0.15 molar. We're going to verify if this is going to be true whenever we have our answer, and in general, you're going to be able to say that this is correct as long as x is lower or equal than the 10% of your initial concentration. Some professors actually use 5% instead of 10%, but that depends on the level that you're doing, and if you're taking analytical chemistry or general chemistry. Okay, so this is a reasonable threshold for general chemistry. With this, we can replace the value of the equilibrium concentrations as x times x multiplied and on the denominator 0.15 minus x. We can do the small x approximation, which is going to allow us to transform this into x squared divided by 0.15. So the value for x is going to be equal to the square root of 0.15 times 10 to the minus 4.79. Or you may notice that this is quite similar to an expression that tells us that is equal to the square root of C0 times the basicity constant. So the result of this is going to be 1.56 times 10 to the minus 3. So this value is going to be equal to the concentration of OH minus, as we can see from our ice table. So the concentration of OH minus is equal to x, equal to 1.56 times 10 to the minus 3 molar. Thus, the value for pH, POH, is equal to minus the logarithm of this concentration, which is 2.8. And finally, pH would be equal to 14 minus POH, which is going to be equal to 11.2. And this would be our final answer for pH of the solution. So with that, it would be all. Thank you very much, and have a good one.